Can you guys hear me? Yeah. Awesome, awesome. How is everybody doing? You guys had fun today? It's an amazing event, right? So my name is Irakli. I'm CTO and co-founder of a healthcare technology startup here in the city called ReferWell. Basically what we're trying to do, we're trying to bring the communication between the doctors or generally medical providers from 20th century into 21st century, right? If you ever been to a doctor and they said, go see a specialist, how many of you have gone through that experience, right? So how many of you have enjoyed that experience, right? So usually they will tell you go see a neurologist or a cardiologist or something like that, and then it's up to you to find the specialist and make sure that they accept your insurance, that the times work, that the location works. It's basically a multivariate equation solving, and it's so frustrating, so stressful, and so confusing that the data shows us that about 26 million people just in this country every year are referred to a specialist, need medical care, and never make it, which is really sad. And also, even if you make it, then the doctors will start this phone tag, trying to get the information about you, or sending things over the fax. We thought you can do things a little bit better in the 21st century, so that's what ReferWell is. You may not care about that, but what you may care about is that we built this intelligent system and we used microservices architecture. And as we were building this, we also learned a whole bunch of stuff about it. So what I would like to do today, I'd like to talk to you about the blind spots, what I call blind spots, which is basically the topics that I don't see discussed enough about microservices, and yet I think they are very, very important, especially if you're implementing microservices and not just talking about microservices as a theoretical thing. So how many of you would like to hear about the blind spots? All right? Okay, let's do this. So it's a three-part presentation. I know I'm standing between you and your alcohol, so I'll try to go as fast as possible. But we have to cover some ground. So the first thing I wanted to understand was, why do people actually care about microservices? What are the motivations of even doing microservices? Should we even do this thing, right? And there seems to be a revolution going on. Anybody here the fan of this TV show? Right? Am I the only one? So there seems to be a revolution. A lot of people are interested in microservices. There's the whole API360 dedicated to it. Why? Right? Where does this interest comes from? And the thing is that right now, if you look at literature, this is the list you're going to get why you should be adopting microservices, right? Especially if you're talking to the kind of people who read Martin Fowler or Sam Newman or others, this is kind of the canonical list, right? And this is a good list. I've used this list to sell microservices to multiple organizations very successfully. The problem with this list that I have is that this is the current motivation right now of the early adopters of why they want to do microservices. And with any big technological or product innovation, there is this adoption curve, right? This is from the book called Crossing the Chasm, which is kind of the classic in the product marketing space. So this book tells us, and the authors tell us, that the motivations for early adopters, usually for something like this, are very different from the motivations that early majority has. And the early majority is when something goes mainstream, right? So now that Fowler, which usually solves everything for us, right, as far as theory goes, now that he has sold us why early adopters want to use microservices, I wanted to understand, once it goes mainstream, since it seems to be a revolutionary thing, what will be the motivation for those people, right, for the early majority? And to understand what the motivations are, I have some ideas what this may be, but to explain the thought process, we have to note that there is another really big tide rising in technology. Microservices is not the only revolution. There's another one called containers, right? And as a matter of fact, I would say 10 times, 100 times more people and organizations are hyped up about containers than microservices. The kind of organizations that don't even care, don't even consider microservices are all in on containers, because containers have a promise of giving you universal deployability. You can ship your containerized application anywhere, and that's a really big promise. I would even go as far as say that containers will soon, probably in a number of years, become like cloud. Right? So in 10, 20 years ago, a lot of people spent a lot of time considering, should we go to the cloud, should we not go to the cloud? I would say it's safe to say at this point that for a majority of the organizations, that's not a question anymore, right? The cloud is the obvious choice for 99%. There may be still some cases where it's not, maybe military, maybe NSA, but I think they have their own clouds, right? But either way, the containers will be like that. It will be an obvious choice. And the thing is that when you talk about the containers, microservices seems to be an obvious architectural choice for containerized applications. The thing is, it doesn't make much sense to containerize a big, large application. It really doesn't. It goes as far as, if you look at the Docker, which is kind of de facto container solution right now, it's not the only, but it's kind of what everybody thinks when they say containers. In Docker documentation, they directly say that do not containerize something large, something that is multi-processed, right? You can do it, but people look weird at you, will call you names behind your back, do all kind of nasty things. So it's not really what you're supposed to do. You should be putting in containers single process, single purpose things. It sounds like microservices, right? So if containerization will be the ubiquitous way of deploying applications, it's really a small leap to assume that microservices as the architecture that's really facilitating that kind of development will also be the obvious choice for containers. So we have been used to thinking of containers as a tool that we use in microservices in the early adopter stage, but the reality is when everything goes mainstream, we have to see how much bigger the container movement is, and we should assume that containers will actually drive the adoption of microservices, not just be the tool in the microservices architecture, because many more people are interested in containers, right? So it will be a kind of gateway drug to the microservices. So another thing that really bothers me, and I don't think it's talked enough, is that a lot of conversations about microservices is all about code, like how small the code should be, how modular the code should be. It's all code, 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 code. And it's kind of weird because microservices are APIs, and the I in API stands for interface. So why are not we talking about interfaces like Eric kind of did in the earlier talk, right? So kudos to Eric, but I want to follow up on that, right? When we're architecting microservice systems, we should be really caring about how loosely coupled interfaces are. Not just how modular our code is, but how loosely coupled our interfaces are, because otherwise, we will never be able to deploy to microservices independently. And if we cannot deploy to microservices independently, then we have to do all this coordination, and coordination kills distributed systems. So a system in which interfaces are not loosely coupled, regardless of how small your code is and how modularized your code is, will never achieve the premise of microservices. Right? And it's a really hard problem because designing APIs that are loosely coupled is actually really hard work. Right? And especially with the dominant API interface design technologies that we have now, or styles that we have now, like REST or SOAP or others, they make things pretty tightly coupled. So fortunately, there is an API style. There's probably many, but there's a specific one that seems to be more common and that I have personally had most success with. It's called hypermedia API style. So if you don't have experience with hypermedia, it's basically an API style where instead of just marshalling around data, the payload of your API response or request also contains some meta information that tells you what you can do with the API, not just data, but what they call affordances, which is like the actions you can perform with the API directly in the response, not in the documentation, in the API itself, right? Which makes such APIs very evolvable, very browsable, very explorable, and very loosely coupled. So hypermedia APIs is one of the API design styles that is very, very good for keeping API interfaces loosely coupled. From my experience, I would very highly recommend exploring it at least when you're designing your microservices so that all your efforts don't become about the code. And last but not least, I want to spend the most amount of time talking about data modeling and the data storage in microservices because this is the space where the teams I have worked with in my current company, in many other companies, basically everywhere, everybody I talk to who does microservices, this is the biggest stumbling stone. Right? This is where teams get in a lot of trouble. And the reason to that is because microservices brings this very new and tricky constraint, which states each microservice needs to encapsulate all of the data that it operates on. There cannot be any data sharing between microservices. The motivation for this constraint is very simple. If two microservices share data model, then they cannot be deployed independently. And we've already said how important deploying microservices independently is. But this constraint is actually also a very hard one. Because if you think about the decades of software development before distributed systems and before microservices, we've always integrated at the data storage level, right? We've had all these components and all this modularization, but then all of them would talk to the same Oracle or MySQL or whatever your database of choice happens to be. MongoDB and CouchDB are just exactly as problematic, by the way. Would still talk to the same storage where the same data space is shared by different components. And that's a problem, but that's what we know how to do. So how do we avoid getting into that problem? So most common guidance that you will get right now, this is a known problem, this is not a blind spot, we'll get to the blind spot. The most common guidance you will get to how to avoid this data sharing currently is use domain-driven design. Right? That's kind of the least common denominator answer to this problem. Domain-driven design, how many of you have heard of domain-driven design? How many of you have actually practiced domain-driven design? So lesser hands, right? Domain-driven design is a great thing. It comes from Eric Evans's book. It basically talks about things like bounded context, and it basically says when you have a large complex system, it's not just one domain model that serves that complex system, but you can break it up into multiple subsystems that kind of form this subject matter expert bounded context, which are encapsulated from the business side. So therefore, there is not as much need, just naturally, organically, as much need to share data because naturally they are bounded. So if you design your microservices to align with your bounded context, then your technology aligns with your business. You don't have to share data, yada, yada, yada. So that's all very cool. There are a couple of other books that are good about this subject. A similar sentiment in Sam Newman's book, who is a very good thinker in the microservices space, who says one of the other techniques you can use to avoid this data sharing is think about capabilities, right? Don't get into this habit that we all have. We start building an application and we start drawing the tables, right? Don't do that. Think about the capabilities. How you're going to store the data is an implementation detail. If you do things like the capability-oriented design, you will again avoid some of the pitfalls of sharing data. So both of those things are very, very useful, but here is the blind spot. They don't actually help you achieve the level of granularity you're going to need with microservices. The biggest question in the microservices world that everybody asks is, how micro is micro? Right? And some people come up with, oh, micro is not small enough for us, we're going to do nanoservices, and all kinds of silliness like that. There is no real good answer to this. Everything everybody tells you, like 2 pizza teams, number of lines of code, garbage, right? The reality is it has to be small enough. And if we say that domain-driven design is how we size our microservices, let's see how small domain-driven design says things should be. Well, that's interesting. So this is what Von Werner says, the author of one of the great books about the subject. He says, bounded context should be as big as it needs to be in order to fully express its complete ubiquitous language. If you're not familiar with domain-driven design, it's very linguistically driven. Basically, bounded context is explained as the subsystem of your domain where people speak the same language. So accounting subsystem, accountants have their own lingo. Financial subsystem, financial people have their own lingo. So as far as you're in the confines of the same lingo, that's the bounded context. It's a very simplified version, don't quote me on this, but basically that's what it is, right? So as long as you're speaking the same language, that's the bounded context. That's what Von tells us. And that's a problem. Because think about your organizational design, right? So if you have too many bounded contexts, that means you have too many teams that speak different lingos. So imagine a company where people speak 200 different languages. The cross-team communication in that company is going to be fun, right? But at the same time, from the technological perspective, you need your microservices to be as small as possible. You absolutely will end up needing at least the level of granularity that gives you 200, 500 microservices. Right? So the bounded context alone cannot give you that granular things because you're going to get in trouble with your organizational design. And if you don't have small enough deployment units, which is what microservices are, you're not going to be able to achieve this 100 times a day deployment of Etsy is the gold standard, yada, 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 right? So there's a conflict here. So what do we do about this? In general and known, I think we all agree DDD cannot give us what we need. So apparently, one of the problems we have, and the reason we cannot achieve this granularity and we get in this trouble with data sharing, is the kind of data modeling we use, right? For decades now, we've been trained to use this relational data modeling. And the reality is this is not the only way you can model data persistence, right? So this is what we're used to. This is an example entity diagram. It's not a conventional UML. It's just a sketch, so don't hold me responsible for this. But you get the point, right? You have some entities. They have some relationship with others, many to many, many to one, all that fun stuff that most of you have probably done many, many times. This is how we do things, but we could do things in a different way. And the two design patterns that, if you're not already familiar with, I would encourage you to look into are event sourcing and CQRS that approach data modeling differently and allow you to not share data but still do things in a very granular way. So let's explain what event sourcing and CQRS are. So this is Greg Young, who is kind of the father of the whole event sourcing CQRS thing. And basically he says this is the kind of data storage when instead of storing the state of entities, you're storing a sequence of facts. A fact is basically a metadata about some event occurring, right? So this sounds all very abstract, and yet all of you are familiar with it, whether you have ever heard event sourcing or not, because this is how accounting works. This has ties with the accounting ledger. So classic example of this is your banking account. So in your banking account, the number, the value that matters the most for most of us is the balance, right? We have high balance, we're doing good. Have low balance, we have to worry. So that value is actually not a primary value that is stored. If you have ever developed a banking system, there's no object, the property of which is the current balance of your account. It's a derivative value. What bank actually stores is all the transactions that have happened that lead to that value. That's event sourcing, right? So if you call up your bank, you say, I have $20,000 in my bank account. I think I should have 50. What's going on? They're not going to tell you, sorry, ma'am or sir, that's what our table kind of says in Oracle, so deal with it, right? They're going to give you all the transactions and show you how you got to this value. Similarly, we can store things in the same way instead of doing all these tables and relations. And we'll see how that helps us in microservices in a second. But before we get there, you may already notice a problem with that, right? So if any state is the derivative value of the sequence of events, and events have been happening for a while, this sounds like a system that could be very non-performant, right? Anytime I need some value, I have to run a function that calculates all of the events and then see what's going on. Like that can take some time. And that's true. If you just implement it in that naive way, it could be very slow. That's why event sourcing is a lot of times used with another design pattern called Common Query Responsible Desegregation pattern. So basically what it says is the way you store your data is not the way you query your data. So you store your data as the database of record as a sequence of events. And when these events occur, some other systems can listen to these events and immediately react to it by creating highly optimized indexes. You can think of them as like cache, right? So every time the transaction happens in the bank, that is my data. That's what I go to when I want to look for the truth. But I also recalculate the balance. So every time I need to just display you the balance, I can get it from the cached index. I don't have to recalculate it every time. So that's basic trick that we use. So it can be both very performant as well as very reliable. And in the end, this is what event sourcing and CQRS can lead us to, right? So this is a data model of some imaginary medical system. It's not the one we actually use, by the way. But I wanted to show you that it's not just for accounting, right? Healthcare is as far from finance as it can possibly be, other than both industries being very, very convoluted. I can talk to you about that over the alcohol. But this is basically some entities, like patient visits some doctor, and they have some insurances. Like, this makes sense, right? So this is how we would do things. This is what in the event sourcing model, the same data storage would look like, right? There's no entities. It's a sequence of events. Patient created, insurance added, billing info added. Can we calculate, show of hands, can we calculate everything that was on this slide through this slide? Who says yes? Who says no? Thank you. Another thing I want you to notice about this is, look at this diagram, how crafted each type of entities, like we have types of entities, they have different shapes and the colors, and we take a lot of time trying to get the right data model. Like, everything is a snowflake, its own precious thing, right? Here, everything is the same thing. Every event looks exactly the same way. Anybody can help me what this reminds you? Another thing that this reminds you, everything looks the same? Containers, right? If you have used containers, every container looks the same. Whether you put Oracle in it, or MySQL, or Postgres, or MongoDB, or Cassandra, whatever you put in it, container is a container. The same way an event is an event. And this is important because when you're using event sourcing in microservices and you're using containers in microservices, it's the same philosophy, right? That similarly looking containers that contain some information, the contents may be different, but it's very homogeneous. Right? So it's completely different. One is deployment, one is data storage, but the same kind of thinking. That's why they work really well in microservices. So this is an example. So this is where the rubber meets the road. This is how the event sourcing and secure can help us in microservices. So let's think about a patient's visit microservice. Like, a patient visit can include a lot of stuff, right? There could be information about insurances and demographics and clinical notes and all those things. So designing a bounded context that is small enough so you can describe all kinds of things you can ask about patient and the patient visit is actually very hard. You can't get too small if you try to do that. But with event sourcing, I can design a tiny microservice, the only job of which is record every event related to the visit. And then every other question I have, like what insurances does the patient has, what is their name, what is their birth, I can design as a separate microservice that is not storing the data, just listening to those events, only indexing the events that it's interested in, and creating the index, and then very quickly answering any of my questions. And I can go as small as I want using those two very, very simple design patterns. Right? So this is how we solve the problem of data storage and the granularity. There's one more thing I want to talk to you. I said, I know that I'm standing between you and your alcohol, but there's one last thing that we need to note before we leave, which is a lot of people talk about the complexity of doing microservices. And in general, we want to use microservices before it gets into early majority and everybody uses it, right? At this point, we want to use microservices for complex systems, right? That's where the gains are. But complex systems have this trait that you can't really simplify complex system arbitrarily, right? In any complex system, it comes from Fred Brooks, so it's not my idea. But in any complex system, there is essential complexity and there is non-essential complexity. You can remove non-essential complexity through better design, better architectural style, microservices versus monolith. You cannot remove essential complexity using any tooling, including architecture. If you remove essential complexity of the system, you're removing the essence of what the system does. So if that's true, for really complex, like essentially complex systems, what's the benefit of using microservices? We cannot simplify it, right? So apparently the benefit is that we're moving complexity from one space into another. What microservices does, everybody has probably heard already that the ops side of microservices is very complicated, right? You have to deal with containers. You get a lot of simplification in code modification, code maintenance, all those things. Absolutely get simplification in how much simpler the code you write or the designs you make are, but you get complexity increase on the ops side. You have to now deal with containers, service discovery, have all of these thousands of APIs floating around possibly. It's much more complex. right? So we don't overall simplify the system, just move the complexity to another area. How is that exciting? Like if you move dirt from here to there, does that really excite you? Well, apparently, the reason it's a good thing because in this spot we don't have a vacuum. In that spot we have a vacuum that cleans up the dirt. And that's really what microservices does. Ops is the area of software engineering that in the last 10 years, in the last decade, I would say, we've gotten really good at automating. Doesn't matter how complex the ops size is, we can put Ansibles and containers and Kubernetes and all those new things that we have and automate the heck out of it, right? So we're okay if the complexity in the ops, as long as we have the talent, as long as we have gone through the exercise, in the long run, complex ops does not scare us. Complex code development, complex architecture, we have not automated yet. So that is why microservices is such a big deal. This is why, while it's just moving the complexity from one area to another, it's moving it into the right direction. And that's how microservices is a great thing. Thank you very much.